Hi everyone, in this video we are going to discuss about theorem number 15 from the geometry of circles. The theorem says there is one and only one circle passing through three given non-collinear points. So if we have 3 points which are not collinear, then we can draw only one circle through those points. That's exactly what we have to prove. So let's get started with the proof. Let's suppose we have 3 non-collinear points like this, point A, point B and point C. And next what I'm going to do, I'm going to connect A with B, that's a line segment AB. And next I'm going to connect A with C, that's a line segment AC. Next what I'm going to do, I'm going to draw the perpendicular bisector for the line segment AB. Let's suppose this pink dotted line is the perpendicular bisector here, and let's suppose it intersects the line segment AB at point D. Next, I'm going to do a similar thing. I'm going to draw the perpendicular bisector for the line segment AC. And let's suppose the bisector intersected the line segment AC at point E. Next, we have to understand a couple of things. First of all, how many perpendicular bisectors can we have for a line segment? Well, we cannot have more than one. We can have exactly one perpendicular bisector for a given line segment. So in this case, if we talk about the line segment AB, then how many perpendicular bisectors can we draw? Well, we can draw only one perpendicular bisector. And similarly, for the line segment AC, there also we can draw only one perpendicular bisector. We really cannot draw more than one, because if we talk about bisector, it has to go through the midpoint of the line segment. And how many midpoints we have? Well, we have only one midpoint for a line segment. And then how many perpendiculars we can draw at that point? Well, just one. We really cannot have 2-3 different perpendicular bisectors. We can have just one perpendicular bisector. So because a line segment can have only one perpendicular bisector, so in this case, for the two line segments here, the line segment AB and AC, we can have just one perpendicular bisector for each of them. And because A, B and C are not collinear, that means their perpendicular bisectors will not be parallel. That means the bisectors will intersect at some point somewhere, because two non-parallel lines will definitely intersect at a point, and only one point. They will intersect at only one point. And let's name that point as point O. I have that denoted in yellow. So let's assume that the two perpendicular bisectors intersected at point O. I hope the construction is clear up to this point. Next, what I'm going to do, I'm going to connect O with A, B and C. I have used yellow dotted lines there to connect A, B and C with O. Now let's take a look at these two triangles here, triangle OAD and triangle OBD. If you look at those two triangles, you will see that they are actually right triangles, because OD is perpendicular on AB, so they are just two right triangles next to each other, and AD is equal to DB because OD is the perpendicular bisector. So AD and DB, they are equal portions, and the angles ODA and ODB, they will be 90 degree each, because OD is the perpendicular bisector, and also OD is a common side between the two triangles. So using the SAS criteria of congruence, we can say that those two triangles are congruent triangles. And because they are congruent triangles, then obviously the corresponding sides will be of equal length. That means OA will be equal to OB. Similarly, let's take a look at the other two triangles here, triangle OAE and the triangle OCE. If you look at those two triangles, again we have the same type of situation there. AE is equal to EC because OE is the perpendicular bisector for the line segment AC. So AE and EC, they will be the two equal portions of the line segment AC. And also the angle OEA and the angle OEC, they are right angles. So those two triangles are also right triangles. And then OE is a common side. So here again, using the SAS criteria of congruence, we can say that those two triangles are also congruent triangles. And because they are congruent triangles, we can say then the corresponding sides will be of equal length. So we can say OA will be equal to OC. Now from those two results, what can we say? Well, we can say that OA is equal to OB is equal to OC. So far we have been able to prove two things. One thing is that OA is equal to OB is equal to OC, and also we have proved that O will be the only point where the two perpendicular bisectors will intersect each other. And now if we draw a circle using O as the center and OA or OB or OC as the radius, then we are going to have a circle like this. Using a particular point as the center and a particular radius, we can draw only one circle. We really cannot draw 2, 3, 4 different circles, meaning circles of 2, 3, 4 different sizes. It will be only one circle there because O is a specific point based on these two line segments AB and AC. O is the point of intersection for their perpendicular bisectors, and then OA and OB and OC, they are of equal length. So if we use that as the radius and then point O as the center, we can draw only one circle. So from here we are able to prove that we can draw only one circle through three given non-collinear points. As long as the points are not collinear, then we can draw only one circle passing through those three given points. I hope the proof made sense. Thank you for watching. See you in the next video.